Okay, next we go for tutorial haloalkane objective question. The first question, what is the IUPAC name? Okay, for the following compound. First of all, you must identify the parent change. So over here, the parent change, okay, is here. There are two carbon, meaning there is 18. So you can eliminate the answer which is not 18. So the A is wrong. And then check there are how many substituent. Okay, using another color. So substituent, 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 substituent. You should check over here, right? There are total 4 coral. So meaning that this compound right, involve tetracoral and 1 fluorine. So okay, we check which one is the position 1 and which one is the position 2. If we look at this one, right, this carbon with 2 substituent, this carbon with 3 substituent. So the highly substituted carbon is as the C1. So this is C2. So that's why at position number 1 there are 3 coral and position number 2 there is 1 coral. So the answer obvious is donkey, which is 1112 tetracoral. And then position number 2 there is coral, 2 coral 18. Remember, number between the number must be comma, and then between the number with an alphabet must be a dash hyphen. Okay, now we proceed for question number 2. Haloalkane are more reactive than correspond alkane. Why? Actually, this is due to the halogen or haloalkane are polar compound, while alkane is non-polar compound. Okay, so polar with dipole-dipole interaction, and then alkene non-polar with London dispersion forces. So dipole-dipole is stronger than London dispersion forces. So this you have learned in chapter 4. Okay, question number 3. Next question number 3. Which of the following compound is least easily hydrolyzed by aqueous sodium hydroxide? So you must know sodium hydroxide actually is strong nucleophile. Okay. If strong nucleophile, you must have some idea. Okay, if strong nucleophile is for SN1 or SN2. Okay, so let's check the difference between SN1 and SN2. So SN1 is first order reaction, which only depends the rate is only depends on the concentration of our alkene. And then carboxylic ion as an intermediate, that's why this is two-step mechanism using weak nucleophile. So the order of reactivity of SN1 is prefer tertiary. So this is very important, tertiary. For SN2 is second order reaction because the rate of the reaction depends on the concentration of haloalkene and nucleophile. Involve a transition state, and then this one is one-step mechanism, and then using strong nucleophile. So based on the case just now, right? Okay, sodium hydroxide actually is strong nucleophile, and then it prefer methyl halide or primary halide. Okay, so in this case, methyl halide or primary halide, we check. Okay, so maybe this one is prefer primary or methyl halide. Okay, if we check over here, A and B actually is a benzene ring. Because you check the number of carbon and number of hydrogen, the ratio is 1 to 1. So, but for A, there are 2 bromine. That's why only 4 hydrogen atoms. So, meaning that the halogen for compound A is directly bonded to the benzene ring. Okay, for case number B, the bromine is not directly bonded to benzene ring, but the methyl group over here means the benzyl, okay, benzylic alkyl halide. Okay, this one is attached to benzene ring, so it will affect it as well. And then for C is secondary haloalkene, and then for D is primary haloalkene. So meaning that, okay, this one also primary, yeah? Okay, and then this one cannot be classified because not attached to the sp3 carbon, but we know this is a benzene, the 2 bromine is attached to benzene ring. So, prefer primary. Okay, prefer primary meaning that over here, okay, this one the most easiest one. Okay, D is the most easiest one. So if I arrange, right, so this is number 1. Okay, between B and C, although C is secondary haloalkane, B is primary haloalkane, but C is easier because B is a benzene haloalkane. If you still remember, if you look at question number 5, arrange the following compound in order of increasing reactivity towards SN1 hydrolysis reaction. Explain your answer. The concept actually is the same. Okay, benzylic. Okay, the benzylic carbocation is the most stable because the positive charge can be delocalized over an extended pi orbital system forming 4 resonance structure. While secondary, okay, this is secondary carbocation is more stable than the primary carbocation. The more stable the carbocation, the more susceptible it is to nucleophilic attack. Therefore, the more reactive towards SN1 reaction. So you have to take note, even though, okay, this is primary haloalkane, but due to this benzylic carbocation, means this group is attached to the benzene ring. Compared to this bromine, even though secondary, but it is just attached to a normal saturated hydrocarbon, means cyclohexane. Okay, always remember benzene carbocation more stable. That's why. Okay, if we check back to this question, okay, so the least easily, okay, is B. Okay, the third is B, and then the most, okay, means the least easily, the most difficult one is 4, because these two bromine directly attached to benzene ring. That's why the answer for 3 is A. Here you have to have the concept. Okay, always remember. Okay, the difference between the SN unimolecular nucleophilic substitution and the SN2 bimolecular nucleophilic substitution. SN1, okay, normally go for the tertiary haloalkane, undergo 2-step mechanism using weak nucleophile, and the SN1, okay, 1-step mechanism using strong nucleophile, prefer the methyl or primary haloalkane. Okay, but be careful, be careful. Sometimes, right, the SN2, even though it's primary haloalkane, it will undergo SN1, okay, due to the steric effect. Okay, you have to alert steric effect. Why there is a steric effect means there is a bulky group with hidden, okay, hidden or not allowed, okay, the backside nucleophilic attack happen. So later we check, is there any question about this? Okay, now we proceed for question number 4. Iodoethene react with hydroxide, SN2. Okay, this is strong nucleophile as well, SN2. What is the effect of doubling the concentration of hydroxide? Okay, because we know, right, SN2, again, SN2 is depends on the concentration of halogen, haloalkane and nucleophile. So if we double the concentration of nucleophile, meaning that, okay, the rate of the reaction is double as well. Here, because SN2 depends on the concentration of nucleophile as well. So concentration double, the rate of the reaction is double. Okay, now we look at question number 5. A bromoalkene is hydrolyzed aqueous solution. The rate equation for the reaction is, okay, so we know this is SN2. SN2 will prefer primary haloalkane. So we check which one is primary. Okay, this one is secondary. This one is benzene. Okay. Okay, this one is primary as well. So, okay, the concept same as just now. So the answer is A. Okay. Which of the following compound is formed when cyclohexane is boiled with alcoholic potassium hydroxide? Alert, this is cyclohexane, haloalkane. Okay, alcoholic potassium hydroxide. Okay, when we answer this kind of question, we have to alert. If potassium hydroxide, there are two situations. One is potassium hydroxide, okay, ethanol. Okay, ethanol means one of the alcohol, ethanol, and then heat. Okay, this one actually is undergo elimination. Another one is KOH aqueous or NaOH aqueous. This one is undergo nucleophilic substitution. So in this case, alcoholic. So the answer is B. Okay, number 7, green-up reagent. This is a famous question because green-up reagent very useful. It can form alkane, primary, secondary, tertiary alcohol, and carboxylic acid. So which statement is true about the organometallic compound? Okay, based on here, yes, it has a nucleophile, very obvious. No, it's polar. And then undergo substitution reaction. Not really. Actually, if you check, right, the question actually is undergo nucleophilic addition. When you react with the carbonyl compound, right, it is undergo nucleophilic addition reaction. So its carbon atom has a positive charge? No, because magnesium is more positive than carbon. So meaning that the carbon actually is with negative, is partially negative. That's why the answer is A. Okay, number 8. Which statement is or are true about reaction of 2-chloro-2-methyl propane with aqueous? Okay, in this case, right, we will check. This is, we draw it, propane 1, 2, 3, propane, and then there's 2, okay, and then chloro. Okay, chloro over here, meaning that this is tertiary haloalkane. If tertiary haloalkane, if you check, right, it prefer SN1. Am I right? Yeah, tertiary haloalkane prefer SN1. Okay, and then two-step mechanism using weak nucleophile, carbocation as the intermediate. Okay, so the rate is dependent on the temperature. We didn't mention about it, so ignore. The rate is proportional to the concentration. Yes. Okay. The rate is proportional to the concentration of sodium hydroxide. Okay, it actually is independent. So now we check. Okay, is it temperature is one of the factors? Okay, if you base on the technique answer, right? Okay, there is only the choice only is A is 1, B is, if we check the choices, right? Okay, A is 1, B is 1 and 2, C is 2 and 3, and then D is 1, 2, 3. Over here we confirm 2 is correct. So from here we know, okay, actually 1 also correct. So the rate is dependent on the temperature. At the same time, if you still remember the rate of reaction, right, directly proportional to the temperature. So that's why the answer number 1 is correct. Number 2, yes, the rate is proportional to the concentration of the haloalkane. Okay, because SN1 is independent of the nucleophile. That's why number 3 is wrong. Okay, now we look at question number 9. What is possible product M of the following reaction? So this is bromine or water, so meaning they undergo nucleophilic substitution, means the bromine will replace by the alcohol. So for sure, 2 is correct, straight away. Okay, and then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 1, 2, 3, 4, 5. Okay, so all with 5 carbon. And then we check 1 and 3 whether correct or not. Okay, if we check for here, this one is secondary. Okay, secondary haloalkane. And then it can undergo rearrangement. Once it's undergo rearrangement, here will form the tertiary carboxylic ion. When here from the tertiary carboxylic ion, right, meaning that, okay, the alcohol might attach to, okay, this position. Okay, this position, meaning that the answer D is correct. Okay, when you form the tertiary carboxylic ion over here after rearrangement, right, it will form a tertiary carboxylic ion. Then the alcohol will substitute over here. Okay, for the case number 1 is not correct because it possible to form the primary carboxylic ion and then form the nucleophile substitute over here. So that's why the answer is C, 2 and 3. We tend to form a more stable compound. Okay, not the least stable compound. That's why answer A, number 1 is not acceptable. Okay, which of the following reagent can react with haloalkane in nucleophilic substitution? So the answer is 1, 2, 3 because all are nucleophile. Okay, that's all for the haloalkane objective question discussion. Thank you.